Welcome to the Ecotechie. In today's video, we are going to learn how to build a decision tree model in Python. In my previous video, I had given you a conceptual understanding of what exactly decision tree are and what exactly do you mean by information gain, Gini index, the different type of univariate splitting criterion, the nodes, and so on and so forth. Since it was a lot of theory, I decided that let's look at the practical aspect of it. So, without further ado, let's get into the practical part of decision tree. So, we will first and foremost import the necessary libraries. Import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, import cbon as sns, import warnings dot filter warnings. We are going to ignore all the warnings which turn up. Now let us run this code. So there were no errors and it has been successfully run. Now we are going to import the dataset. For this study, I have taken the iris dataset, the classic dataset. Ask any data scientist or anyone who is into analysis, the first thing they would be learning is about iris dataset. It's the most classical dataset. So I decided that why not just perform decision tree on the iris dataset. So I have taken the dataset from the Kaggle website. You can also get it at UCI Machine Learning repository. I'll provide the link for the same in the description below. So df is equals to pd dot read underscore csv. So let's run this. Now let us look at the head of our data. I hope everyone knows what iris is. Iris is a kind of flower. Now, what we are trying to do is we are given the sepal length, the sepal width, the petal length, and petal width, and we are told to identify whether this is iris setosa, iris versicolor, or iris virginica. So, these are the different types of iris. And how are we going to distinguish them? By their sepal length, sepal width, petal width. Now, if you look over here, you cannot apply decision tree model directly over here because over here your species is non-numerical in nature. So first, what do we have to do? We'll have to first convert the species which is non-numerical column into a numerical column. How are we going to do it? By using label encoding, because we have learned that label encoding is way better than one hot encoding, because in label encoding we do not increase the dimension of the data. So from sklearn dot pre-processing, import label encoder. Now we'll create an object for label encoder. We'll call it LE. Now it's the easiest way. LE dot fit underscore transform. Which column do I have to transform? I have to transform the species column. So I'll just copy paste. Otherwise, I may end up making spelling errors. And if I make a spelling error, then there is going to be a wastage of time. So I write df. Now we have learned that label encoder does not have a in place equals to true parameter. So we'll have to reassign the column. So df equals. Now let us run this code. Now if you check our data frame, so let's check df.head. So in species you have 0 where there is setosa, and where there is versicolor you have 1, and where there is virginica you'll be having 2. Now let us get into the modeling. So modeling and the steps involved in modeling is same across all the models. You take any model, whether it is XGBoost, decision tree, or any model for that sake, all have the same four steps in modeling. So first we have to divide our data into x and y. So over here we do not want the ID column. The ID is not going to give me any information regarding whether it is versicolor, whether it is setosa or virginica. So it is better that we drop it. And your sepal length, sepal width, petal width, that will ensure your species. So that becomes your independent variable. So we write it in x. X is equals to df.iloc. I want all the rows, but I do not want the first column. So it is 0, I'll drop 0. And I do not want the last column because that is going to be my dependent variable. So I write 1, 2, minus 1. And y is equals to df dot iloc. I need all the rows and I only need the last column. Now let us run this. So we have successfully divided our data into X and Y. Now we have to divide our data into training data and testing data. So from sklearn dot model underscore selection import train underscore test underscore split xtrain xtest ytrain ytest is equal to train underscore test underscore split x comma y comma test underscore size is equals to zero point 0.2. You may take the test size as per your convenience. Random underscore state is equals to 1. There is no need to write random underscore state. I am writing so that your answers and my answers are one and the same. Now is the last step. You don't have to worry about anything. All you have to do is build the model. Now from sklearn dot tree. Now we are going to import decision tree classifier because here it is a classification problem. So from sklearn.tree import decision tree classifier. Remember there is decision tree regressor as well. So you have to mention that I'm doing classification, so I want this classifier out. Now let's create an object DTC. It's equals to decision tree classifier. Now the last few steps. DTC dot fit. I'm going to fit it on X train and Y train. And finally ypred is equals to DTC dot predict. I'm going to use only X test for my prediction. Now let us run this code. Once the model is in place, we are only worried about the accuracy. Now let us see what the accuracy is. From sklearn.metrics import accuracy underscore score. Print accuracy underscore score y test comma ypred. Now let us run this code. So we are getting a very high accuracy of 96%, which is a pretty good accuracy. If you can, try applying KNN, try applying SVM and look at the accuracies. Mostly decision tree gives a much better accuracy. Now we have to look at how to build the decision tree. It's very simple and it's like a two lines and then our decision tree will be in place. From sklearn.tree import plot underscore tree. So you can also use GraphViz So for GraphViz, you have to just write pip install GraphViz or conda python GraphViz. But here I'll be doing with plot tree. Now we will just write an object DTC is equals to plot underscore tree. Now there are several parameters in this plot underscore tree. Now let us look at those parameters. So you have something known as max step. So if you want to check the parameters, all you have to do is press shift and tap, and then all the parameters will come. When you shift and tap 4 times, then it will be shown in the half part of your laptop. So you have your decision tree. So basically, you're asking what you want to do. And then you have max depth, that is the maximum depth of the representation. Then you have feature names. So you'll have to write the column names, like you have petal length, petal width, sepal width. Those will become your features. And then your class names. So your setosa, versicolor, virginica becomes your class names. And you are going to label all. And in field, by default it is false, but we are going to keep it at true. And we have impurity. We had already discussed about impurity. Node is when set to true should id number on each node. Proportion, when set to true, change the display of values and or samples to be proportions and percentage. So when rounded, your boxes will be rounded, it will not have sharp edges. And precision tells how many digits after the decimal point should you consider. And then you have your matplotlib axis, the font size, and so on and so forth. So there are these many parameters which are involved in preparing your decision tree. So the first parameter was decision tree. So let's do that. So decision underscore tree. Now we will write DTC. DTC is the object that was created. The next parameter, if we see this, the next parameter is max depth. Let's leave it at none itself. And here you have feature names. So I'll just copy paste this feature underscore names, comma. Feature underscore names is nothing but df and column. Now the next one, if you see, it is class underscore names. So for our class names, we know that it is setosa, versicolor, and virginica. Setosa is small, versicolor, virginica. Now, in field, we will write true, and at last, we have precision. You can give any precision that you like, and then you have rounded. Now, let us run this code. So now our entire thing is ready. Now we have to just click on run and see what exactly is the result that we get. So we get a decision tree which looks something like this. I will just zoom in a bit more so that you all can see, or I'll just increase the size over here. So I'll just increase the size of the graph. So, in order to make this graph a bit huge, I have added one more command, that is plt.figure fix size is equals to 100 comma 100. So by default it will be around at 20 comma 10 or 10 comma 10. So that time it was not clear. So now let us understand what this decision tree is. So here you have the petal length which is less than zero point 0.8. The Guinea is 0.6649. The samples is 120, value 39, 37, and 44, and class is Virginica. Now, this class gets divided again. If your guinea is like 0 and samples are 39, value 3900, then you have a class Setosa. And petal length less than 1.65 and guinea 0.493, samples is equals to 81, values, and it is class Virginica. Now this Virginica gets divided again. So if your sepal width is less than 4.95 and Guinea is 0.18, then you say it's versicolor. Now in this versicolor also there are two ways. If Guinea is 0, then you have versicolor, and if Guinea is 0.32, you have Virginica. And when this Virginica got broken down over here, if your sepal width is less than 4.85, you are in the Virginica class. But if your Guinea is 0.75, you again become Virginica. And if your Guinea is 0, you are again Virginica. And over here you are again seeing division. So basically you have a set of if then conditions. If sepal length is less than 3.5, then it is a Virginica. If sepal length is so and so forth, then it is Setosa. If petal length is this much, it is versicolor, or so on and so forth. So this is the way the entire decision tree works, and I have shown you a graphical representation of decision tree. I hope everyone would try this on their own, because Iris is a beautiful data set and a project. If it is shown in your web portfolio, it gives a lot of effect, because it is one of the classic data sets which most of the data scientists and machine learning engineers use across. I hope the idea is clear for one and all. Do like, share, and subscribe to the Ecotechie. If you have any queries, please feel free to post it in the comment section below. Thanks for watching.